have looked at the definitions of oxidation and reduction. And then I want to tell the pure science and O-level students, there is no chance your school or the O-levels will test you about gaining oxygen or losing hydrogen. Okay, usually when they ask you to explain, we have to use in terms of electron transfer. Okay, so metals will lose electron to form positive ions. Okay, and metals undergo oxidation. So remember oil rig, oxidation is lose, right? So since metals, they all form positive, for example, your sodium, number 11, right? The electronic configuration is 281. So it will lose the one outer electron and it will undergo oxidation because oxidation is lose electron. Okay, another example, magnesium will lose 2 electrons to give you Mg2 plus 2E. Okay, so this reaction, this equation over here is what we call the half equation. Okay, half equation not including this, right? So my magnesium metal loses 2 electrons to give you magnesium ion plus 2 electrons. Okay, so how do you write this is that you just write the charge, right? Magnesium naturally forms Mg2 plus, right? And if I have a 2 plus here, I should put a 2 negative to balance out the 2 plus to get something neutral, a neutral metal. Okay, non-metals, what about them? Non-metals will gain electrons to form negative ions, so they undergo reduction. So non-metals, example, your chlorine. Yeah, electronic configuration 287, you will gain 1 electron to become 288, right? So reduction is gain electrons. So non-metals undergo reduction. Okay, example, chlorine, which is neutral, because there are 2 chlorine atoms in the molecule, you will gain 2 electrons, 1 each, to form 2 Cl minus, 2 chloride ions. Okay, so this is how we write the half equation, and when we write the electrons, we always write where the electrons is added, and we don't write this minus the electrons. Okay, I wrote this one in is to help you see that since I gain electrons on the right side, on the product side, on your starting material, on your reagent side, you should lose the electrons. Okay, so balance the electrons to obtain an overall equation in terms of electron transfer. Okay, so for example, I have copper forming copper 2 plus, right? Since the product is 2 plus, it must gain 2 electrons to become neutral on the product side. So actually this part I am losing electrons. So oxidation is lose. So my copper metal undergoes oxidation as it loses 2 electrons. Okay, and then what happened to the silver ions or your silver metal, right? The silver ions gain electron because Ag plus gain electron to become Ag. Okay, and then we have to balance out the electrons over here, right? So we balance out the electrons based on your half equation, right? So in this case, my copper lost 2, right? It lost 2, but my silver only gained 1. Okay, so in this case, because it lose 2 electrons and it gained 1 electron, the electrons are not balanced. So in terms of redox, your electrons have to be balanced. Okay, so how do I balance it? I have to multiply the silver half equation by 2. So I multiply everything by 2, meaning to say you will have a 2 in front of your silver ions, 2 in front of the electrons, and 2 in front of your silver atoms or your silver metal. Okay, so now your copper lost 2 and your silver ions gain 2. Your electrons are balanced. and then we will combine your overall equation together, right, with the balanced equation. So my copper here gain 2 electrons, sorry, copper over here, right, and my silver ions, 2 silver ions plus 2 electrons. And then everything on the product side, I have my copper 2 ions over here, 2 electrons, and your 2 silver metal, right? So when you balance out everything, put everything on the product side, everything on the reagent side, right? After you balance it out already, you look at things that appear at both sides, which is my 2 electrons. So the electrons are transferred, right? From here to 2 electrons to here the 2 electrons. Since they appear on both sides, then I can cancel them. So your overall equation will be copper plus 2Ag plus give you Cu2 plus 2Ag. Okay, so in terms of, if we count just atom by atom, right, number of atoms, then your copper and 1 silver and copper 2 plus and 2 silver feels like it's balanced. Okay, but in terms of electrons for redox, it is not balanced. Okay, so this is your correct answer. Okay, so let's try the checkpoints below as an example. So same thing, what we will do as a first step is to write the half equation where my aluminium solid became Al3+. Okay, so my aluminium solid become Al3+. So since the product side is positive, here I'm actually gaining 3 electrons to make it something that's neutral, right? So I have the 3+ have to gain the 3 electrons to become something that's neutral. Okay, the other half equation will be my Pb2+ became Pb solid. Okay, and because the starting material side now is positive, you have to gain 2 electrons. Then you can get something neutral. Okay, so you have 2+, you have to gain 2 electrons, then you can get something that's neutral. Okay, so what does these equations mean? Is that the aluminium, right, from Al3+. So when it gains electron on the right side, it is actually losing the 3 electrons here. Right, so your metal tend to lose electrons, and these 3 electrons will be gained by your Pb2+. Okay, but now the Pb2+ is gaining 2 electrons and not 3. So the electrons don't add up. So what must I do? I must find the lowest common multiple of 3 and 2, which is 6. So this one you have to times 2 to everybody. And this one you have to times 3 to everybody to make it 6. Okay, so your overall half equation will be 2 aluminium, give you 2 Al3+ plus 6 electrons. Okay, and this one will be 3 Pb2+ plus 6 electrons, give you 3 Pb. Okay, so repeat, right, when you times 2 to everybody, the electrons is actually losing 6 electrons. And these 6 electrons that are being lost is gained by the 3 times of the Pb2+. So combine these two equations together, you get 2Al, everything that's on the starting material side for both the half equation, plus 3 Pb2+, okay, plus, by right is 6 electrons, give you 2 Al3+ plus 6 electrons over here, okay, plus 3 Pb. So I'm just combining all the starting material and your products. Okay, and then let's cancel the things that appear on the both sides, which is your 6 electrons and your 6 electrons. So this is your overall equation. 2Al plus 3 Pb2 plus give you 2Al3 plus 3 Pb.